All right, in this example, I'm just going to go through using the Doppler effect as a way of determining how fast an object is moving. This problem is very similar to how police actually use the Doppler effect to determine the speed of cars. So what the police officers do is they send out an ultrasonic, as in a sound with a frequency that's so high you can't hear it, pulse. It bounces off of the car, and when it bounces off of the car, because the car now becomes the source of the sound through the reflection, that the frequency that returns is shifted depending on the speed of the vehicle. Based on that shift, based on that change, they can use the Doppler effect formula to work backwards to determine how fast that object is moving. The numbers in this example aren't going to be necessarily well, the frequencies are too low because they would use ultrasonic frequencies, so they're not accurate, but it does give the basic idea of what they're doing. So they have a frequency of 1034 hertz that's being observed at 1050. So what this means is that this is the original and this is the observed. So somehow this frequency was created, but this is the one that was observed. So how fast is the source of the sound moving relative to the observer? Using the formula, since the observed is higher, we can recognize that the object must be coming towards. So we use the formula for towards because the apparent frequency is higher than expected. We need a speed of sound in this example, and I've forgotten to include a temperature. So let's just pretend the temperature is 20 degrees Celsius. And as a result, we can say the speed of sound is 344 meters per second. With that in hand, then, let's plug these guys in. The observed frequency is 1050 hertz. The original was 1034 hertz. So now we're going to solve for the velocity of the object here. I'm going to multiply both sides by this binomial. That'll clear it from this side. And it'll come up here. And then I have to remember to distribute that 1050 hertz to both terms when I multiply the binomial in on the right-hand side. I'm going to move the 1050 to the left-hand side, make it positive, and move the other, the 355,000 to the left. So the difference between those two things is 5,504. Dividing both sides by my 1050. 5.24 meters per second. So the object's moving at 5.24 meters per second. It wasn't much of a shift in a frequency, so it's not that surprising that the velocity of the object isn't that great. Just for perspective, because I always think in terms of kilometers per hour, this works out to about 19 kilometers per hour.